45, integrals of inverse trig functions. So if you remember, we've talked about the derivatives of inverse sine, inverse tangent, and those things. You have those memorized, yay. So the derivative of inverse sine is 1 over the square root of 1 minus x squared, and the derivative of inverse tangent is 1 over 1 plus x squared. So I told you for the derivatives, those are really the only two that I've ever heard of being on the AP test. My students have never told me differently. So those are the only two that you really need to know. But notice how we do have this one, and then cosine is the same, but we gain a negative, right? And then these two are the same, except what happens? We gain a negative. So really, if you did want to memorize all of them, I would just memorize this one as well, because then cosecant, inverse cosecant is the negative of that, okay? But like I said, these are the two most important forms. So it's like, well, do we really need this? So like looking at number 1, I'm guessing after we've done 6 pages of homework on U-substitution, you think that we should do a U-substitution in this problem, okay? So don't write this, but if you try that and you're like, u equals 1 minus 4x squared, du is going to be negative 8x dx, we run into a problem, okay? Because even if I take that negative 1/8 over, I don't have an x up here to replace. Okay, so we've had situations where we have too many x's, right, on top, where we're like, oh, we, have an extra x. I'm going to solve for u, or I'm going to solve for x and replace with u's, right? But we've never had a situation where we're missing the x that we're trying to replace. Okay, so this will not work with our traditional, like, letting the u be the part that's underneath the square root. So when that happens, what I want you to think of are two forms. So we could want either something to look like this, in which case we're going to have inverse sine of u, or we want it to look like this, in which case we're going to have inverse tangent of u. So it does still involve a u substitution, but it's not the u that you think. Like, we're used to putting it as whatever's underneath the root, right? So which of these two forms, so form 1 or form 2, do you think we're trying to get it to look like? 1. Why? Because you see a square root in there, right? It's the one that has the square root. So we're trying to make it look like that first form. So this is what we want. We want it to look like 1 over the square root of 1 minus u squared. So if we want that, what should u be?
4.
Close. Good job, Caitlin. She says 2x, right? Because this entire spot right here needs to be u squared. So u has to be 2x. So we're letting our u be 2x. Then our du is 2 dx. So we have that 1/2. 1/2 du replaces the dx. So as I write this, I have 1 over the square root of 1 minus u squared, and that dx, like I said, was replaced with 1/2 du. And that's the form we want, right? And this is a definite integral. We did have numbers. We had x values before. X values going from 0 to 1/2. So let's change those as well. So what should my u values go from? Yeah, we're plugging in right here. So if I plug in 0 for x, I do get 0 for u. And if I plug in 1/2 for x, I get 1 for u. All right. So I'm going to have 1/2 inverse sine of u going from 0 to 1, which is 1/2 inverse sine of 1 minus inverse sine of 0. So I don't know how in-depth you went with inverse sine in pre-calc. I think we did a bit of it in summer pre-calc, if you took summer pre-calc. Not a ton, but I feel like the people still remembered it because it's recent. Okay, if you're not remembering this, inverse sine is what we call a one-to-one function, meaning that there's one solution for this. It's not like multiple things. And what we're saying is the sine of some mystery angle is equal to 1. We're finding the mystery angle. And I know that there's an infinite number of solutions where sine is equal to 1. The first one would be pi over 2. And then you have every rotation around the unit circle, right? We would do like pi over 2 plus 2 pi k, right? But inverse sine is restricted only on the right side of the unit circle. So our answers can be between negative pi over 2 and pi over 2. So the solution that we want is when sine is equal to 1. So when you see inverse sine of 1, that answer is pi over 2. It's the angle that gives me a sine value of 1, where that angle is restricted to a certain part of the unit circle. It's between negative pi over 2 and pi over 2. Do you guys know why it's restricted to that part versus cosine's restricted up here? Any guesses why sine's here? Yeah, it's kind of like where one full period, where it's we call it it passes the horizontal line test. It's 1 to 1, where that works. But if you also think about on the unit circle, the sine is negative 1 here, the sine is 0, the sine is 1, right? 1/2 root 3 over 2. Do I have every single number represented on the right side of the circle? Yeah, but if I do the top part of the circle, sine would just be between 0 and 1, right? So anything that I picked in here, I'm only getting sine values between 0 and 1. That's not going to give me all possibilities, right? So we need to restrict it to just the right side of the unit circle. This is making sense? You guys are totally dying, I can tell. All right, how about inverse sine of 0? What's that? What mystery angle? Sine of what angle gives you 0? It is 0, so our answer is pi over 4. All right, I expect you to know how to do inverse sine of a number, right? If it says something like inverse sine of 4, which it might on your homework, you might have a weird one that says that. Do we know inverse sine of 4? No, it's fine. You can leave it as inverse sine of 4. That is a number. Okay, but if you can simplify it and find what those are, then do that. All right, Helen.
Why does u equal 2x and not 4x?
Because if you do 4x squared, right, we actually get 16x squared. We only wanted 4x squared.
Okay.
So u had to be 2x, so then when I square it, 2x times 2x gives us the 4x squared.
Okay.
Right, we want u squared to be in there. Basically, you're taking the square root of that term.
Okay.
All right, so looking at this one. Okay, you kind of go through the whole process. You're like, can I do a U-substitution? You could do u equals the denominator, x to the 4th plus 9. Does that work? No, because I would have 4x cubed. I would need an x cubed on top. Okay, so these could be mixed in with other ones, right? Is this still a U-substitution? Yes, but we want to get it in one of those two forms. So we want this one. Notice how there's no root. We want it in the form 1 over 1 plus u squared, or 1 over u squared plus 1. So 2 red flags here. The first one has to do with a 9. What number do we want that to be?
3, 1.
We want it to be a 1, right? So need a 1 here. Some of you guys are really good at this. Some of you guys are not going to be good at this. This is okay. I have a feeling Cole is going to be all over this. How am I going to get that to be a 1? Where? The whole thing? Just divide the whole thing by 9? I divide the top by 9 and I divide the bottom by 9. Okay, if you don't like that, because it creates a fraction within a fraction, you can multiply by 1/9 and multiply by 1/9. Does that make more sense to you? All right. I don't like this 1/9 on top. I pull it out front. But I like it on the bottom. I like that x to the 4th over 9 plus 1 because that's what I wanted, right? Ding, ding, ding. You have a 1 there. All right, we're almost there. We want this bottom to be u squared plus 1. So u is equal to, so Kellen, this is what you're asking. So you're going to take the square root of that x to the 4th over 9. So what should u be then? You're not Kellen. X squared over 3, right? She's just so excited. All right, so it's x squared over 3, which I'm going to write as 1/3 x squared because, you know, some people try to do the quotient rule on that stuff. Don't do the quotient rule. So what's du? Yeah, it's going to be the 1/3 times 2x, which is 2/3 x dx. Are we getting there? 3 over 2 du equals x dx. And we start replacing. So our x dx is replaced with 3 over 2 du. You can put the du on the top if you want. My students always hate du's on the top. I don't know why. Yeah? I don't know. What about that 1/9? We do. It's out front with the 3/2. What about the x to the 4th over 9 plus 1? What does that become? U squared plus 1. Are we where we want? Yeah. So we have 3/18, which is 1/6. And if I integrate 1 over u squared plus 1, I get inverse tangent of u plus c. So 1/6 inverse tangent of x squared over 3 plus c. Okay, so they're complicated. They're a little weird. You got this. You can do it. I do not like it, Sam, I am. I do not like green eggs and ham. All right, this one. Same idea. So what do we want? Yeah, we want 1 over the square root of 1 minus x squared. So we got some changing around to do. Now this is a little bit tricky. It is 1/2. Good job, Phil. All right, why is it 1/2 and not 1/4? Yeah, because it's underneath that square root, right? So if you're underneath the square root, we're dividing by, dividing by 4 under that square root, which is dividing by 2. Do you guys understand what he's saying? Maybe, not so much.
Yeah.
So let me write it. Maybe this will make more sense. So I'm going to do the square root of 1/4, and I'm going to do a 1/2 on top. Does that make sense? Do you guys see how those are the same? So what this becomes is a 1/2, which you can pull to the front if you want, 1 over the square root of 1/4 of 4 is 1, 1/4 of x squared is x squared over 4, and then our dx. So u should be x over 2. That is correct. We're going to let Kellen have the next one, aren't we? Do you get it though, Kellen? Do you get why it's u equals x? She's got it. All right, now x over 2. Again, don't do quotient rule. This is 1/2 x, right? So du is going to be 1/2 dx. So we start replacing. We're like, I got my 1/2 from before. I got 1 over the square root of 1 minus u squared. I'm going to have my 2 from the du part. So I'm going to multiply by 2, which cancels those out, right? So I get inverse, oops, almost wrote tangent, inverse sine of u plus c, which is inverse sine of x over 2 plus c. All right, you guys try number 4. So try 4. All right, so did you guys divide by 4? So you should have 1/4 on the top and bottom, right? So you get a 1/4 dx. You're going to have your 1 like you want, and you're going to have 9x squared over 4. So this part right here needs to be your u squared. So what did you guys let your u be?
3x.
Yeah, 3x over 2, which is 3 over 2x. So then du is going to be 3 over 2 dx. So we're going to gain a 2/3 out front. So as we start replacing, we still have our 1/4 from before. We're going to have our 2/3 from the du. And we do get our 1 over 1 plus u squared like we want. So we're going to get 2 over 12, which is 1/6 inverse tangent of our u plus c. So sometimes as I'm plugging in my u, I'm like, oh, I'm not going to write the u part. I'm just going to be like, oh, my u was 3 over 2x. And that's our answer. Feeling better about these? They're weird at first, I know. All right, let's do one more. All right, so sine over 1 plus cosine squared. So I was saying if it was going to be 1 minus cosine squared, that would be sine squared, which would be sine of x divided by sine squared, but it's not 1 minus cosine squared, it's 1 plus, right? So you can try to do the U-substitution of the whole denominator. It doesn't work because you don't have 2 cosine x sine x in the numerator. but we can still make it into the form 1 over 1 plus u squared, right? So what do we let our u be then? Cosine of x. So then our du ends up being negative sine of x. So as we start replacing, we gain a negative. So as I plug in my 0 and my pi over 2, I have cosine of 0. So it's cosine of 0 over here, 1. Cosine of pi over 2, 0. Yeah, does that bother you? So we can switch it so it becomes positive, and we go from 0 to 1. So we get inverse tangent of u going from 0 to 1. So we're going to have inverse tangent of 1 minus inverse tangent of 0. These are numbers that you should know. So like sine, inverse tangent is restricted to the right side of the unit circle between negative pi over 2 and pi over 2. Every answer you get should be between those two values. You're never going to be like 11 pi over 6. Right? That doesn't work. 11 pi over 6 you would write as negative pi over 6. So what do we have? So tangent is equal to 1 where? Ah, good. Pi over 4. Perfect. And tangent is equal to 0 where? 0. So pi over 4 minus 0 is pi over 4. The next one, do you see that it's still this form? What would your u be for the next one?
1 over square root of 4 minus x squared.
What?
Oh, sorry. I thought you meant the equation that we'd use.
Oh, I see.
Yeah.
I was like, where are you getting this? Okay, yeah, u is equal to e to the just plain x, right? Do you see how u squared, if you have u squared, that's e to the x squared. We multiply our powers. So it's e to the 2x. That's what's happening there. So this becomes 1 over the square root of 1 minus u squared, as Cole was saying. So it's going to be inverse sine of u plus c, and our u was e to the x. That's our answer. Okay, we've done things like that where that's been our original y value, right? And we've been like, oh, y prime, it's inverse sine. It's 1 over the square root of whatever we had in there times the chain, right? Do you see how those are the same, just in reverse? All right, so let me give you your homework. And I'm going to give you your U-Substitutions quiz.